In 2021, Intel replaced its CEO for $20 billion. Intel generated $70 billion annually with 110,000 employees across design and manufacturing. The chief executive reported to 11 directors who met quarterly. That cadence had worked for decades. By 2014, it would become a constraint. Intel owned its fabs, fabrication plants in Oregon, Arizona, and Ireland. Future image, fabrication floor. Engineers ran a tick-tock model, process shrinks alternating with new architectures. When nodes moved from 45 to 32 to 22 nanometers, margins followed. The board's role was oversight. That worked until the roadmap stopped advancing. The 10-nanometer process was supposed to follow 14. Instead, 14-nanometer production extended year after year. Yield targets slipped. Product teams redesigned chips to extract more performance from an aging node. Capital once earmarked for transition-funded optimization. Slides still showed progression. Dates moved to footnotes. Competitors interpreted the same delay as opportunity. Taiwan's Semiconductor manufacturing company offered advanced nodes to external designers. Advanced Micro Devices, no longer operating its own fabs, placed orders with TSMC and released processors built on smaller geometries than Intel's latest offerings. Intel described its situation as execution complexity. Analysts began describing it as lost leadership. Inside governance materials, recovery remained the baseline assumption. Directors approved multi-billion-dollar upgrades to internal facilities rather than large-scale outsourcing. Incentive plans continued tying compensation to operating margin and cash return. Share repurchases persisted. Manufacturing variance appeared manageable against strong financial metrics. 3 proposals stalled over 18 months. Expansion of external foundry relationships was deferred pending internal stabilization. A product priority shift toward high-performance desktop chips over data center parts was postponed. A long-range capital plan for a new U.S. fab was tabled until yields improved. Each deferral appeared isolated. All depended on the same premise. Internal process would regain pace within 2 cycles. By late 2019, that premise limited alternatives. AMD server processors gained data center contracts. Future image, server racks. Cloud providers cited performance per watt advantages. Intel retained scale, but segment share shifted. Engineering leaders requested permission to outsource selected components. Granting that request would have required acknowledging that integration no longer guaranteed parity. Previous votes committing capital internally would have required revision. In 2018, Bob Swan became chief executive after serving as CFO. His background was finance, not semiconductor engineering. The board described the appointment as stabilizing. Capital discipline intensified. Share repurchases continued. Manufacturing updates became shorter sections in investor presentations. The tick-tock terminology disappeared, replaced by process and packaging innovation. Engineers who once briefed directors directly now submitted reports through CFO review. Manufacturing became a finance problem. Meeting frequency increased. The Technology Committee expanded its mandate to review milestone progress in detail. Independent assessments supplemented management summaries. What directors saw as transparent oversight, engineers experienced as second-guessing. Technical decisions now required business justification. Design cycles stretched to accommodate governance review. Public narratives shifted faster than internal assumptions. By 2020, TSMC announced 5-nanometer production at scale. Apple Inc. transitioned its Mac line to internally designed processors fabricated by TSMC. Future image, product launch stage. One major customer disappeared from Intel's roadmap. Externally, integration looked optional. Internally, it remained foundational. The interpretations diverged completely. Investors described Intel as a design company constrained by manufacturing. Management described Intel as uniquely advantaged by controlling both. The same integration was framed as liability outside and strength inside. Share price volatility tracked quarterly updates. Employee briefings emphasized long-term resilience. Capital commitments tightened the path. Intel announced multi-billion-dollar investments in new fabs in Arizona. Future image, construction site. The projects were presented as recommitment to process leadership. Outsourcing at scale would have reduced the volume necessary to justify those facilities. Continuing internal focus required compressing development timelines already under strain. In January 2021, Intel announced that Pat Gelsinger would replace Swan. Gelsinger had started his career at Intel and later led VMware. The transition was framed as acceleration. The choice of a technologist shifted authority back toward engineering. It did not reverse prior capital allocation. Within months, the roadmap was reformulated. IDM2 combined internal manufacturing with expanded use of external foundries. Intel would also manufacture chips for third parties. The model acknowledged that exclusive reliance on internal nodes was no longer sufficient. Earlier proposals to deepen foundry relationships resurfaced under new terminology. Building fabs required subsidies. Subsidies required demonstrating long-term competitiveness. Demonstrating competitiveness required hitting process milestones. Each step depended on the previous, though no one had designed it as a chain. Announcements about U.S. and European expansions referenced pending government incentives while node transitions were still in progress. Performance thresholds became public markers. Intel 7, Intel 4, Intel 3, renamed process nodes aligned with industry language, carried defined launch windows. Missing a milestone would register immediately in customer planning cycles. Compensation metrics incorporated manufacturing execution more explicitly. Oversight now attached to calendar dates rather than internal projections. Becoming a foundry introduced new constraints. External clients required service-level agreements, predictable yields, and assurances of neutrality. Foundry operations demanded structural separation from product divisions. Reporting lines adjusted. Integration remained, but compartmentalized. What had been an internal coordination challenge became a customer-facing obligation. The earlier deferrals returned under pressure. The postponed expansion of foundry partnerships became central to strategy. The deferred capital plan transformed into accelerated construction. The unresolved product priority debate reappeared as wafer allocation between internal designs and external clients. Questions first raised in 2017 resurfaced within tighter timelines and public disclosure. Market share data offered mixed signals. Certain segments stabilized. Others continued facing competition from AMD and TSMC-backed designs. Annual capital expenditure exceeded $20 billion. Cost structures expanded before external foundry revenue matured. Stability required utilization. Utilization required customers. Customers required consistent execution. The authority structure shifted, but constraints remained. Engineering regained prominence under Gelsinger. The board maintained expanded oversight. Government incentives tied funding to domestic manufacturing commitments. Competitors continued advancing nodes. Each quarterly update addressed milestones achieved and milestones adjusted future image, earnings slide. The file documents committee expansions, renamed process nodes, fab construction, and a CEO succession framed as acceleration rather than correction. It does not document a single vote that abandoned integration. What remains unclear is whether manufacturing delays forced strategic adaptation, or whether adherence to integration delayed the manufacturing recovery itself.